Okay, today we'll look at matrices solved by Gaussian elimination. Now this topic is quite interesting and takes a lot of focus. So don't despair if you don't get it right the first time. It takes a lot of practice. Okay, so the good news is eventually you just use the calculator to solve, but you want to understand why it works. Therefore, I'm going to show you an example where you can see the steps and try yourself. Please know that there's not just one way to do it. It depends on what variable you would like to drop, and that is what will change your approach. Now, I'll be working with the first two and add them in order to drop out my y. Okay, so this will be my target. As you know, to solve a system means to find out what each variable represents, what it's equal to. So that's what we're going to do. Now, the first one I'll keep. Okay, so basically I kept this one. And then that adding process is applied. The two are added together to then result in this. Now try to keep your variables organized and your equal sign as well, so that there's a string and you don't get confused. Always copy what you're not ready for. Now, this is your system in 3 variables. So this is the guy that changed. Okay? After adding row 1 and 2. That's where the change happened. And what happened exactly? Y disappeared. So now on the second equation, I'm down to 2 variables, which will make it easier for me to find out what they represent. So I'm going to go ahead and keep the first one as it is. And now I need a plan. What do I want to do? Okay, what do I want to do? I want to get rid of the y right here. So in other words, I'll be adding, okay, get rid of the y again. And so I'll be adding my row 1 and row 3. But for it to make sense, I have to double row 1. Okay, let's do it. If I double row 1, notice I keep row 1 as is, right? But in my mind, I'm now for the next step to get my third equation going the right way. I will be, oh, this one is 3x. I'll be copying this. And then for the third row, for these to work out well, I'm gonna multiply the first row and add it to the third. So 4x plus 3x is 7x. 2y minus 2y disappeared. Yoo-hoo! 3z times 2 is 6z plus 3z right here. Gives me 9z positive. And now negative 2 times 2 is negative 4 plus 12, negative 12. Negative 4 plus negative 12 gives me negative 16. Okay. So now you may wonder what just happened. Well, what happened was my y disappeared here, which is nice. Now 2 of my functions here are down to 2 variables only instead of 3. So what else can I do? I will now be targeting the bottom 2 equations to solve for z. Okay, so I will have decided to drop x. Okay, or eliminate. Let me just say eliminate. let's eliminate x. How? To eliminate x, I will have to multiply the top by 7 times 7, side thought, and that times -3, let's say. Or multiply the top by -7 and the bottom by +3. Either way, what's happening? So side thought over here. First of all, one thing is for sure. The first equation will stay as is. I'm going to copy it, okay? That's for sure. And now my side thought. Because the changes happen in both, okay, right here and right here, I'm going to write it out. So 3x times 7 is 21x. Then 2z times 7 is 14z equals -5 times 7 is -35. Okay, so I got that, -35. Now the second equation, if I do the same, it gives me 21x minus 27z, because now I'm multiplying 9z times -3, and it's equal to -16 times -3, positive 48. Okay, so now I'll be ready to add these two up, and as I do so, okay, as I do so, I can record what I did. I did 7 times row 2 plus -3 times row 3. And I'm going to go ahead and keep my second row. Okay, so it's going to be my keeper. Because if you just eliminate, like add it up and then you just eliminate, you would lose the number of equations that you need in order to keep going. So that's why I'm going to keep this one, and I'm going to change by addition my third. Okay, this one will be changed. So when I add it up, 21x, oh, there should be a negative, of course, right here. Should be a negative in front since we multiplied by -3. That allows me to eliminate this whole thing. Perfect. And I'm down to -z, -13z. Why? Because this is what I get here. -13z equals +13. Yay, time to celebrate. It actually looks good because it looks like my z is going to be -1. Okay, and check it out. Side thought. Divide by -13. Okay, -13z equals 13. Divide by -13. It gets me to -1. Okay, so finally we got one variable going. And now you simply work backwards and you sub, okay? Sub for z into 3x plus 2z equals -5. 3x plus 2 times -1 equals -5. 3x minus 2. And now you're like, okay, we're getting somewhere here. Plus 2. Oh, look at that. Beautiful. So I thought division by -3. X seems to be -1 as well, just like z. So now sub z and x values in to the first equation to find y. Okay, so now 2 times -1. So basically this is what we're looking at, people, okay? Right here, we're plugging in all of this. Okay, this and this has to move into the first equation, and then we'll see what we get for z, which is, by the way, the final step. That's kind of not for z, for y, because now it's the only remaining variable we don't know yet. Luckily, they're both -1. Notice it does take some focus, because as soon as one thing is off, everything is off. That is the frustrating part with all of it. Okay, so that's -5 equals -2, y equals 3. Okay, so it looks like my y is equal to 3. So let's list what we found as an ordered pair. The solution would be x, y, z, and it would be -1, 3, -1. Okay, you always want to check. Okay, you cannot just quit and say, hey, I got some pretty numbers. You have to check. Okay, so you're going to have to check equation 1, equation 2, equation 3. So you go back to your original, see what it is, and then you plug it in. 2 times plus 3 plus 3 times -1. Is it equal to -2? Let's check. -2 plus 3, that's 1, minus 3 is -2. -2 equals -2. That's good. Now, because you got -2 equals -2, okay? Now the second equation. The second equation was x, you plug that in as -1, you plug it in, minus 3 minus -1. Is it equal to -3? Plus 1, that's it. -3 is equal to -3. So that is correct. Last equation, 3 times -1 minus 2 times 3 plus 3 times -1. Is it equal to -12? And you do the work. -3 minus 6, -9. Yes, I get -12 equals -12. And therefore I know that all of these equations worked out fine for me, and all of them checked. My solution is correct. Celebrate good times, come on. That's it. Okay, again, please know that you don't have to target y first. You could have targeted z, x. You could have worked with different equations to kind of see what you want to eliminate. It doesn't matter which way you progress through the problem. Your goal, however, will remain the same, and that is the isolation of each variable and the final answer to be 3 numbers that your x, y, and z represent. And that obviously only works if it checks for all 3 equations. Okay, so now there's another way to write it. So instead of, and I'm going to show you that very quickly here, instead of having your 2x plus y plus 3z written like this, we are going to use an abbreviated way that allows us to focus just on the numbers. Okay? We're going to focus only on the numbers and disregard the variables. So this is what it would look like. There's a bracket. You keep the number, forget the variable. Don't forget the coefficient of variables that seem to be a standalone situation. So you just copy the numbers, okay? And then I'll just make a solid line like this. This will be what it's equal to, right? And then the bracket will close. So now, second row, in front of x is 1, in front of y is -1, in front of z is -1, and it's equal to -3. Now this, boom. So Gaussian elimination uses this way to write things down and works the problem the very same way, technically, trying to make those numbers happen. Okay, so, but what is it really trying? Let me tell you what it's trying to do. It is trying to create a row of ones diagonally, like this. Okay, so the goal is to make the diagonal show 1 everywhere. And then below, right here, you want to have 0 for each entry. Okay, so this is the goal. Below you want to have zeros. Now, how do you, like, what is that about? Okay, it's about the reduced echelon form. Reduced echelon form. So in other words, you wanted to say 1, and then whatever number technically, yeah? I mean, you could make those zeros as well. It's just more work. 1, and then whatever number you get here, you can live with it. But you absolutely have to have ones across, and then you would get what it's equal to. Okay, so this is your goal, to make this a 1 all along. Okay, so let's get it started. I'm going to copy my numbers yet again, just like I did before. 2, 1, 3, 1, -1, -1, 3, -2, 3, -2. Okay, so this is what we have here. Okay, so this is what we have, and this is what I'm going to do. I'm going to multiply my second row by -3. I'm approaching that maybe differently than the first time, okay? And I'm going to show you that you still get the same answer, all right? So bear with me. Remember, lots of focus on this. Keep, make no changes to the first one. Keep, make no changes to the second one. And now my third one, okay, so I keep this one, change this one. I'm going to multiply, that will be 0. 3 minus 2, okay, that's 1. That's 6, that's -3. Boom. So I got that. Now my goal is to still make this a 0 and this a 0. Okay, that's the goal. In the process, you happen to get those ones going. Okay, that would be your reduced echelon form. So what am I gonna do next? Oh, you know what I noticed? I could even, if I wanted to, I could switch these two so that I have a 1 there. I don't have to switch it. I could just keep it as is, but I will, because you can. I'll show you that it's possible, and I prove to you that you will get the correct answer. So let's not forget the -2 back here. otherwise we'll get confused. Okay, always check, guys, before you move on, because it's just so easy to have flipped something, like with the back values and whatnot, which luckily they both were -3, equal to -3. Okay, so now what I want to do is I want to make this a 0. That's my goal. Okay, so in order to get there, what should I do? I should keep this one, I should keep this one, and I should change the bottom. How? I'm going to multiply row 1, no, row 3 by that and add my row 1 to it. Okay? So copy 2, 1, 3, -2, 0, 1, 6, -3. And now, as I multiplied it and added it up, I get these values. So what did I multiply? This by -2, then I added 2 minus 2 gives me 0 right here. Then I do -2 times 1 minus -2 -2. Yeah, I'm multiplying the third row by -2. So -2 times -1 is +2 plus 1 is +3. So you get +3 here. And fine, we finished that. Notice we're getting closer to the reduced echelon form. We want the zeros here. This triangle of zeros is a must, otherwise you cannot figure out what x, y, and z represent. Okay, so that's my goal. I want the 3 to go away. Okay, so that's my next target here. My 3 right here has to go. Okay, how do I make it go away, guys? How do I make it go away? Now, if you start fidgeting with the first row and the third one, then this value right here gets messed up. You don't want that. So you would have to think of something else to do. Okay, so let's think. What else can you do? Okay, I'm going to multiply this row by -3 and add it to my third row. Okay, so I'm going to keep the top, 2, 1, 3, -2. I am going to then multiply that, but I keep these entries here. Okay, so I'm going to put the words keep, and then the only change happens in my third row. And that, people, leads me to a very nice situation where my x already appears to be -1 when simplified. Because now think about it. This means -13x equals 13. So that means x is -1. You see? So you can divide by -13 and you will see that you get 1 equals -1. So the fully reduced echelon form, well, at least, with the diagonal of 1 is coming up, we're going to get there. Okay, 0, 0, 1, -1. Okay, so I already have my x. And now I can also do the top row. If I wanted to, I can divide that by 2. So that would be 1 half, 3 over 2, -1, 0, 1, 6, -3, 0, 0, 1, -1. So now you have your diagonal of 1s, and there they are. Now you also have your little triangle of zeros. There it is. And beautifully done. We are now going to find my x, y, and z fully. We already know x is -1. We showed that before. We just plugged it in. Now into the second one. So right here, I'm going to go into the second one and see what that represents. As you know, in the middle you have y, and on the right you have z. So I have, considering this situation, I have 1y plus 6z equals -3. Okay, so I still have to find my oh, look guys, hello, we did not find x, we found z, because I still have to find now one at a time, right? So let's go and correct it. Why? Because this one was your z that you found. The third one in line was z. And there it is. Why? Because it's xyz, not the other way, around. There you have it, z. So now we notice that we can now plug in accordingly, because if it was x that we found, we would be like, uh-oh, wait a minute. So that would be y minus 6 equals -3, y equals +3. Okay, so we have y, z, and now x. I am now going to, and it doesn't matter where you go guys, you could use this to find out what your x is, or you can go all the way up. It doesn't matter what row you plug it into, eventually you'll get the same thing. Okay, so I'll just use this row that we just worked with, and I plug that in to show you. So it's 1x plus 1/2 y plus 3/2 z equals -1. It is easier to just go with the integers, of course, but who cares? Make it an integer. Here, times 2, each term multiplied by 2, that would be 2x plus y plus 3z equals -2. Let's go back up into the table to show you that that is exactly what this was saying, not surprisingly so. So this is where you could have plugged in your values right away, and that's what we're gonna do. Plugging in the 3 now, plus 3 times, plugging in the -1 now, -1 equals -2. 2x, oh yeah, look, that just dropped out, so that's equal to -2, x is -1, and that's it. Notice that we are getting the very same answers for x, y, z, all right? -1, 3, -1. And when we go all the way back to our elimination method, when we still used variables, we will notice that we got the very same answer right here as we got with Gaussian elimination, where Gauss was deducing it to this form with the ones in the diagonal and the zeros in that little bottom left, and you get the same answers. Now, do the same with the calculator, okay? Calculator skills. Okay, let's practice that. I hope this helped and you found it to be a good way to see how these problems can be worked out.